This is 3.2 part 2. We're looking at piecewise defined functions. So a piecewise function is just a function where you have to have more than one formula to define the output. So each function right here, each formula is designated for a specific set of x values. So say x is less than 2, we're going to graph this line. Or you would have this output if you're plugging in a number less than 2. And then say you have x is greater than 10 right here. So this only applies to where x is greater than 10. So you'll have several different formulas, at least 2, and they will only be used for when x is in that certain domain. Okay, so let's look at some examples. So this first one, you see you have the 3x plus 2, but only if x is less than 0. That line only applies if x is less than 0. And then you have a different line, so different slope, right here, if x is greater than or equal to 0 or less than 2. And less than 2, so between 0 and 2. And then lastly, you've got y equals -1 if x is greater than or equal to 2. So we're going to sketch a graph of that, and then we'll use that to to identify the domain and range. So first, 3x plus 2, but only if x is less than 0. So let's first graph the line 3x plus 2. So first, the y-intercept is at 2. The slope is 3, so you can go up 3 and to the right 1, or down 3 and to the left 1. So that has a slope of 3 and a y-intercept of 2. However, it says only if x is less than 0, so I have to erase this part of the line because it's only when x is less than 0. Also, since it says just less than, not equal to, that means at 0 I need to have an open circle for this line. Okay, so that's how you graph 3x plus 2, only for x is less than 0. Okay, now I'm going to do the second one, and that's going to be from 0 to 2. So right here we've got a y-intercept of 2, so we do get a point there, because it's equal to 0 for that domain. And then the slope is -1/2, so down 1 over 2, down 1 over 2. Okay, and that's that line. Oops. Okay, but look at the domain. It says for x is greater than or equal to 0, so starting here with a closed circle, and then less than 2, so I need to erase this part of my line, and I need an open circle right here because it doesn't say equal to 2, it just says less than 2. All right, now we'll do the third part of our equation. I'm going to use a different color for -1. So f of x equals -1, which means y equals -1. For x is greater than or equal to 2. So we're down here at -1. And that's just going to be a horizontal line. But only greater than or equal to 2. So I'm only moving to the right of that 2. I get a closed circle there because it has the equal to. And that's it. So think about this. What is the y value for this function when x equals 2? So I'm saying, what is f of 2? Well, if I look at my graph, I have 2 different points at 2, right? But this one on the top, that's an open circle. So it's not actually a point. It goes all the way up to 2, but it doesn't include 2. So that means that the y value is -1, because that's where the point is when x equals 2. You can't have multiple closed circles or multiple points at 2 because then it wouldn't be a function at all. And we're doing piecewise defined functions. So it should always be one of them is open and one of them is closed if you have 2 points at the same x value. So that's how that works. Okay, let's get the domain. So domain going from, we've got this arrow here on the left going from left to right. So negative infinity. And then as I move to the right, see I've got a point here, so I just keep going. At 2, that still is included in the domain because I do have a closed circle there, even though it breaks apart at 2. But then we do keep going forever. We've got that arrow, so positive infinity. There's no numbers that we have to leave out. There's no what you would call holes in the graph. All right, and then the range going from low to high. So I've got negative infinity, I see that arrow at the bottom, and then moving up, up, up. Even though there's a gap right here, you see how there's still a y value on the blue side, the blue line, and so those y values are still included in the range, and it goes all the way up to positive 2. All right, let's look at this one. So first, for x is less than -1, we're going to plot x cubed. So less than -1, so maybe if it helps you, you can draw a little vertical dash line there and only graph to the left of that. Okay, so we're doing x cubed, so that means at -1, I would have -1 cubed. -1 cubed is still -1. We're going to have an open circle there because we are only less than -1. Okay, what about -2? What's -2 cubed? -2 times -2 times -2 is -8. Oh, I'm running off of my graph. So that's going to be somewhere down here. Okay, so then you can draw that curve. And if you did -3, you'd have -27, so that would just keep going down very far, down to infinity. Okay, let's look at the next one. So this one's between -1 and +4. So maybe you would want to draw another vertical dash line there just to tell you where you need to stop. And you're going to graph the line y equals -2, or f of x equals -2. So it doesn't matter what x value gets plugged in, the y value is still going to be -2. So that's going to be the horizontal line at -2. So it's strictly greater than -1, so still having an open circle there. And then strictly less than 4, so another open circle there. Okay, and then we'll do the third one. I like to underline these so we know which line I was graphing. Okay, now, greater than 4, so just going to the right of that line, we're going to graph the square root of x. So what's the square root of 4? That would be 2. So the y value should be 2 there. Open circle because there's no equal to. Square root of 5, well, you could type that into your calculator just to approximate. Should be a little greater than 2. 2.2 is what I got. So at 5, I should just be somewhere like right here. So always just plug the x value in to figure out the y value, and then you can plot the point. All right, so that's what I got for my graph. Let's look at the domain. So domain goes left to right. I've got -infinity all the way up to, now look at -1. Look at the x value -1. Is there a closed circle there? Is there a point at -1? Nope. So this goes -infinity up to -1, but it doesn't include -1. Union. And then we start again at -1. On the purple line, and then you continue all the way to +4. Is there a point at +4? Nope, both of those are open circles, so we can't include the positive 4, so we have to stop. Union, start at 4 again on the green line now, and then see it goes on to infinity, so 4 to infinity. So when you have something like that, that just means you're going up to that number, not including that number, and moving on. So we go up to -1, we stop, then we start on the other side of -1 and continue. We just cannot include -1 or positive 4. Okay, now let's look at the range. So going from low to high, from bottom to top. So the lowest point that you see is actually this arrow, which goes to -infinity. Okay, and then let's move up. Even though there's a gap here, see the blue line does cover that distance from -2 to -1. So you don't have to stop there, but you do have to stop at -1 because there's nothing happening right here for the y values. There's no line graphed right there. All the way from -1 to +2, there's no line graphed. So we're going to stop at -1, and then we're going to start again, not until +2. Since those are both open circles, I did use parentheses. And then you see the arrow on the green one. It is going to go up slowly, but it will go up to +infinity. Okay, a little practice with domain and range there. All right, a cell phone company uses the function below to determine the cost, C, in dollars, for G gigabytes of data transfer. Okay, so here's our piecewise function. So the cost is $25 for gigabytes between 0 and 2. And then the cost is 25 plus 10 times the gigabyte minus 2, the number of gigabytes minus 2, if G is greater than or equal to 2. Okay, so that's the formula or the function that they're going to use to determine how much you're going to pay. Find the cost using 1.5 gigabytes of data and the cost of using 4 gigabytes of data. Okay, so we're going to plug those in. So we're trying to find the cost at 1.5. So we're plugging 1.5 in for G. So that's C, the cost of 1.5. Now, which part of the function are we going to use? Are we going to use the 25 or the 25 plus 10 times G minus 2? 1.5 is between 0 and 2, so we're going to have to use the 25 here. So that would just come out to 25. Now for the 4 gigabytes of data, we're finding the cost when G is 4. So now which part of the domain are we in? Well, we are greater than or equal to 2. So you're going to have 25 plus 10 times plugging in the 4 for G, 4 minus 2. So 25 plus 10 times 4 minus 2 is 2. So that's 25 plus 20. So the cost is $45. And that concludes 3.2.